This is Skills Homework 14, Calculations with Linear Magnifications. And we've got our magic little equation here. So I'll do this in the corner up here. I. Then we've got M. A. And all we have to do is the one that we want, we put our finger over and work with that. So that's all we're going to do. So question 1. The diagram of a cell membrane is 40 millimeters wide. The actual width is 8 nanometers. Calculating the magnification. So we're calculating magnification, so put our finger over that. So magnification is image over actual. Magnification equals image divided by actual. The image, so that's our diagram, is 40 millimeters. The actual width is 8 nanometers, and we need to remember that to do this calculation we need both the units to be the same, and it's easier to express the millimeters in nanometers because you can just work in thousands rather than having a really small number. So converting millimeters to nanometers, we've got to go, it's another 1,000 and another 1,000 again. So there's 1,000,000 nanometers in a millimeter. Still dividing by our 8, and that will then give us our answer. 40 000 000 divided by 8 equals that number there, which is 5 with 6 zeros, so it's 5 million. So that's 5, so I can't write 5, with 1, 2, 3, 1, 2, 3, and as it's a magnification we'll put times there, and that is our answer. Question 2. Calculate the length of a cell drawn 86 millimeters long at a magnification. So we've got our magnification and we've got our drawn length, that's our image, and the actual length is what we're wanting there. So we're wanting the actual. So actual is I over M. So our actual equals I over M. You notice I'm writing this out each time, and I'm putting in the numbers, doing the conversion and doing the calculation, and that's usually a reasonable method of getting it right. So our image is 86 millimeters, and magnification is 4,200. So 86 divided by 4,200 is 0.02047 blah blah blah, and that answer there would give us the answer in millimeters. It doesn't ask for any particular units here, but I'm going to change that to micrometers, a more sensible number. To do that, I'm going to move the decimal place 3 times. So I'm going to go 1, 2, 3. Okay, and I'm going to put it there. And so that's going to be our 20.47 or 20.5 micrometers. Question 3. The picture, so that's going to be the image. We've got actual size of the virus. What is the magnification? So cover up the magnification. M is I over A. Magnification is image over actual. What's our image? The picture is the image, that's 35 millimeters and divide that by our actual, which is 30 nanometers. Again, we need to do a conversion so we work in the same units. So it's easier to do our millimeters. 35, 1, 2, 3, 1, 2, 3. So we're going to, there's a million nanometers in a millimeter. Still dividing that by our 30 there. And we put that into our calculator, so 35, 6 zeros divided by 30 is this number here, 1, 1 with 1, 2, 3, 4, 5 sixes, 0.6, 1, 2, 3, 4, 5 and then 0.6, and we will round that off, I think, to the nearest whole. So 1, 5, but the last one's going to be a 7 because we're rounding it up. 1, 2, 3, 4, 7 times. A little bit complicated with all of our sixes. Question 4. An electron microscope magnifies times 14,000 and its measured radius, so that is the image. What's the diameter? Ooh, look at now, they're trying to trick us here. Radius and diameter. So the radius being half of the diameter. So we'll have to factor that in at some point. So we want in the actual anyway. So we're going to put our thumb over the A. A is I over M. A equals I over M. The image is 41, but it tells us that's the radius and it wants a diameter, so I'm just going to times that by 2 to make it into the diameter. And the magnification 14,000. When we do that, so that's 41 times 2 is 82. Divide that by our 14,000 is 0.0058571. So that would be millimeters. Now I'm going to change that into something more sensible. We'll change that into micrometers. 1, 2, 3. So again, moving this decimal place 1, 2, 3. We're going to move it there and put it there. So it equals 5. Is it 5.8? Is it 5.9? It's going to be 5.9. Because we're going to round that one up. Micrometers. So either of those would do as our answer, because it doesn't actually want a unit. Quite often in exams they'll specify the unit they want. Question 5. A nuclear pore diagram has a diameter of 1 millimeters, and that's the magnification. What's its actual size? Okay, so actual is image over magnification. So actual equals image divided by magnification. Our image is 1 millimeter, magnification is 45,000, and we just put that into our calculator. 1 divided by 45,000 is this horrendous number here. 1, 2, 3, 4 zeros, and then 2, 2, 2. The units of that is millimeters. We're going to convert it into a better unit. Again, it doesn't ask for a particular unit, so technically that's correct, but it doesn't look very good. We could convert it to micrometers, 1, 2, 3, but that would still give us a large decimal. So I'm going to convert it into nanometers. So I'm going to go 1, 2, 3. That will convert it into micrometers, and then we go another 3. 1, 2, 3. that will give us nanometers. So 22.2 nanometers. So either of those are correct, but one looks better than the other. Question 6. A mitochondrion is 0.3 micrometers wide and the diagram magnifies it by 81,000. How wide would it be in millimeters? So it's specifying our final unit now, so we can't use micrometers. Okay. So the diagram is the image. The diagram is the image. So we're having our image, and that is m times a equals magnification times by the actual. The magnification is 81,000 and our actual is 0.3 micrometers. Is 0.3 micrometers. And then when we do that, so 81,000 times by 0.3 is 2430, so 24,300 micrometers. But remember, it wanted it in millimeters, so that equals millimeters. I'm going to move my decimal place 1, 2, 3, so that is 24.3 millimeters, and that's our answer there. Question 7, and we're working with scale bars now. So right, we need to convert this scale bar. So we've got on the scale 20 millimeters equivalent to 3 micrometers. What's the actual size? So if 20 millimeters is equivalent to 3 micrometers, what's 1 millimeter of our scale? So 1 scale millimeter equals 3 divided by 20. So 3 divided by 20 equals 0.15, and it's still the same units there, micrometers. So 1 scale bar millimeter is 0.05, and our chloroplast is 94 millimeters long. So we're going to times that by 94, so 94 times by 0.15, 94 times by 0.15 is 14.1, and it's still in the same units, micrometers. So that's our actual size there. Right, we're getting there now. So we just need question 8. Again, similar sort of thing. What's our scale? So on the scale, 10 millimeters represents 1670 nanometers. So nanometers. So 1 millimeters of the scale represents, so we're dividing that by 10, we need to do the same here, 1670 divided by 10, 167, you do this in your head but I'll do it on the calculator, is 167 nanometers. So one of our scales, millimeter on the scale, represents that many, 167 nanometers. How big is our actual drawing? Is 60 millimeters. So mitochondrion is 60 millimeters on the image, and so the actual size is 60 times by our 167. So times that by 60 gives us our 10020 nanometers, and we could change that, convert that into micrometers. So I'm going to move the decimal place 1, 2, 3 that way. Remember, there'll be less micrometers than there are nanometers. So always, if you're not quite sure which way to move it, think there's going to be less of our micrometers than nanometers, because nanometers are very small. And so that gives us 10.02 micrometers. And our last question. On an electron micrograph, the membranes of the ER measured 2 millimeters. So that's on our image. The actual width is 10 millimeters. This has got to be a mistake, hasn't it? So by the time you read this, you might it might have been corrected. But that's going to be nanometers there. What is a magnification? And so we can just go again. Magnification I over A. Magnification equals I. I've ruined my colour scheme here. I was doing alternate. I was doing all right there. Equals the image. That's 2 millimeters divided by our actual, which is 10 nanometers. We need to make those the same units. So easy to convert the 2 millimeters. So 2. How many nanometers in a millimeter? There's a million. 1, 2, 3. 1, 2, 3. Divided by R10. And you can do this one in your head as well. So 2 million divided by 10 is going to be 200,000. Always helps to know what the answer should be before you put it in your calculator. Then you know if you're doing it wrong. So 200,000, which is that's 5. 1, 2, 3, 4, 5. And that is times, because that's our magnification there. So some practice magnifications.